Hello my friends and welcome back to KrossUSA channel. Today we're taking you on an incredible journey through some of the most advanced manufacturing facilities around the globe. So grab your coffee, settle in, and let's get started. Welcome to RoK's state-of-the-art manufacturing facility in Denmark, where precision meets power in the creation of industrial pressure filter vessels. What you're witnessing here isn't just metalworking, it's industrial artistry at its finest. The journey begins with premium-grade steel plates, typically ranging from 6 to 25 millimeters in thickness, depending on the pressure requirements. Notice how the workers are using plasma cutting technology to achieve those perfectly straight edges. This isn't your grandfather's torch cutting. Modern plasma systems can cut through steel with an accuracy of plus or minus 0.5 millimeters, ensuring each piece fits together like a mechanical puzzle. Now here's where things get really interesting. Watch as this massive hydraulic plate rolling machine transforms flat steel into curved sections. The operator is carefully monitoring the pressure. Too much force, and you'll get stress fractures. Too little, and the curve won't hold its shape. This particular machine can handle plates up to 3 meters wide and exert over 400 tons of forming pressure. The welding process you're seeing is absolutely critical. These vessels will hold pressures up to 16 bars, that's roughly 230 pounds per square inch. Every weld must be perfect. RoK uses a combination of MIG and TIG welding processes, with each welder certified to European pressure vessel standards. Notice the systematic approach. They're creating what's called a double V-groove weld that penetrates completely through the material thickness. This massive furnace is performing stress relief heat treatment. After all that welding and forming, the steel has internal stresses that could cause problems down the road. By heating the entire vessel to about 600 degrees Celsius and then slowly cooling it over 8 to 12 hours, they're essentially giving the metal a chance to relax and settle into its final form. The precision machining you're seeing here is remarkable. Those flanges need to be perfectly flat and dimensionally accurate to ensure proper sealing. The CNC machining center is working to tolerances of 0.05 millimeters. That's about half the thickness of a human hair. Each cut is calculated to remove exactly the right amount of material while maintaining the structural integrity of the vessel. Finally, every vessel undergoes rigorous pressure testing. They fill it with water and pressurize it to 1.5 times its working pressure, a process called hydrostatic testing. If there's even the tiniest leak, the vessel goes back for repairs. It's this attention to detail that makes RoK vessels trusted in chemical plants and water treatment facilities worldwide. The entire process, from raw steel to finished pressure vessel, takes approximately 4 to 6 weeks, depending on size and complexity. What you've just witnessed represents over 50 years of Danish engineering excellence. Now let's shift gears to something completely different. The fascinating world of expanded metal mesh production at Jun & Company. This might look simple, but the engineering behind this process is absolutely brilliant. What starts as a flat steel sheet is about to undergo a remarkable transformation. The feeding system you're watching maintains perfect tension and alignment as the material moves through the line at speeds up to 15 meters per minute. Any deviation in feeding would result in uneven mesh patterns. Here's the magic moment. Watch as the specially designed cutting and expanding machine simultaneously cuts and stretches the metal in one continuous motion. Those diamond-shaped openings are created by making precise cuts and then pulling the material apart in a controlled manner. The result? A mesh that's stronger than perforated metal because there's no material waste. Everything gets stretched and expanded. Welcome to the world of advanced plastic pipe manufacturing with Liansu's impressive LSBP 160 double-wall corrugated pipe extrusion line. This sophisticated system produces the pipes that carry water, sewage, and telecommunications cables under our cities. The process begins with high-density polyethylene pellets, those small plastic granules you see being fed into the system. The beauty of this material is its chemical resistance and durability. These pellets are heated to exactly 200 degrees Celsius in the extruder, where they're melted and homogenized into a consistent flow. Now here's what makes this system special. It's actually creating two walls simultaneously through a co-extrusion process. The outer corrugated wall provides structural strength and flexibility, while the inner smooth wall ensures optimal flow characteristics. Two separate extruders work in perfect synchronization, each maintaining precise temperature and pressure controls. Watch as the molten plastic flows through specially designed forming dies that create those distinctive corrugations. The corrugated pattern isn't just for looks. It increases the pipe's structural strength by up to 300% compared to solid wall pipes of the same weight. The vacuum forming system maintains the shape, while cooling water rapidly solidifies the plastic. The haul-off system you're seeing maintains consistent pulling speed, typically 1.5 to 3 meters per minute for larger diameter pipes. Speed control is critical because too fast and you'll stretch the pipe, too slow, and it won't maintain its shape. The automatic cutting system can be programmed for any length from 6 to 12 meters. Every pipe undergoes ring stiffness testing to ensure it can withstand underground installation pressures. These pipes need to maintain their shape under soil loads that can exceed 50 kilonewtons per square meter. The testing equipment applies controlled pressure to simulate decades of underground service. This production line can manufacture pipes from 110 millimeters to 1,600 millimeters in diameter, producing up to 500 meters of pipe per day depending on size. The entire system represents a perfect marriage of German engineering precision and Chinese manufacturing efficiency. Now let's dive into precision machining with Sandvik Coromant's revolutionary Sawmill 390 damped milling cutters featuring Silent Tools technology. What you're witnessing here is a breakthrough in vibration control that's changing the face of high-speed machining. The secret lies in the internal damping mechanism built into each tool. Inside this seemingly simple milling cutter is a sophisticated tungsten damping mass that counteracts vibrations in real time. Think of it as a shock absorber for your cutting tool. It automatically adjusts to different cutting conditions and maintains stability even at extremely high spindle speeds. Watch the surface finish quality as this tool operates at 8,000 RPM speeds that would normally cause severe chatter and poor surface finish with conventional tools. The Silent Tools technology reduces vibrations by up to 80%, allowing for cutting speeds 50% higher than traditional tools, while actually extending tool life. The surface finish you're seeing achieves ray values as low as 0.2 micrometers straight from the machine. That's mirror quality finish that typically requires secondary grinding operations. This means manufacturers can eliminate entire finishing processes, reducing production time and costs significantly. Whether cutting aerospace titanium alloys, automotive aluminum, or hardened steels, these tools maintain consistent performance. The damping technology automatically adapts to different material characteristics, maintaining optimal cutting conditions throughout the entire machining cycle. This isn't just an incremental improvement, it's a paradigm shift that allows manufacturers to achieve precision and productivity levels that were simply impossible just a few years ago. Here's industrial muscle at its finest, Rodatia Industries' extra heavy-duty flatbed CNC machines that tackle machining jobs others simply can't handle. When you need to machine components that weigh several tons with precision measured in thousandths of an inch, this is your machine. This behemoth weighs over 50 tons and features a bed length of 12 meters. That's longer than a city bus. The spindle delivers 200 horsepower while maintaining positioning accuracy of 0.01 millimeters across the entire work envelope. The secret is in the massive granite foundation and precision ground ways that remain stable even under extreme cutting forces. Watch as it effortlessly machines this large steel component. The cutting forces here would destroy smaller machines, but this system absorbs vibrations and maintains precision through its massive structural design. The automatic tool changer can handle cutting tools weighing up to 50 kilograms, tools so large they require their own lifting mechanisms. Welcome to the future of electric motor manufacturing at Jinkang's fully automated production facility. What you're about to see is how modern electric motors, the heart of everything from household appliances to industrial equipment, come to life through precision automation. The process begins with laminated steel stator cores. These aren't solid pieces of steel. They're built up from hundreds of thin laminations, each just 0.5 millimeters thick. This reduces energy losses from eddy currents. Watch as the automated assembly system stacks these laminations with perfect alignment. Even a small misalignment would cause motor inefficiency and vibration. Now comes the fascinating coil winding process. These robotic winding machines can insert copper wire into stator slots with incredible precision. The wire gauge, number of turns, and winding pattern are all precisely controlled. This particular line handles wire ranging from 0.8 to 2.5 millimeters in diameter, winding at speeds up to 1,200 turns per minute while maintaining consistent tension. The rotor assembly you're watching involves precisely balancing rotating components. Even tiny imbalances, we're talking about fractions of a gram, would cause vibration and premature bearing failure. The automated balancing system can detect and correct imbalances of less than 0.1 gram millimeters. For brushed motors, the commutator assembly requires precision soldering of individual segments. The automated soldering system maintains temperatures within 5 degrees Celsius and completes each joint in exactly 2.3 seconds. Quality cameras inspect every solder joint, rejecting any that don't meet the strict standards. The final assembly brings together all components with precision fitting. Bearing installation requires force control within 50 newtons to prevent damage while ensuring proper seating. Each motor undergoes comprehensive testing, including no-load current, starting torque, and vibration analysis. The testing station runs each motor through its complete operating range, measuring efficiency, temperature rise, and electrical characteristics. Motors that don't meet specifications are automatically diverted for analysis and rework. The production line can complete one motor every 45 seconds, with each unit traceable through its complete manufacturing history. This level of automation ensures consistent quality while reducing manufacturing costs, exactly what's needed in today's competitive global market. Here's something truly remarkable. Walter Tools demonstrating complete component machining on a single WFL machine. What you're witnessing challenges the traditional approach of moving parts between multiple machines for different operations. This isn't your typical lathe or milling machine. It's a hybrid that combines turning, milling, drilling, and grinding operations in one setup. The component you see being machined would traditionally require 5 different machines and multiple setups. Here, it's completed in one continuous process, eliminating setup errors and reducing manufacturing time by 70%. Watch the seamless transition between operations. The automatic tool changer holds over 200 different cutting tools, from turning inserts to complex form cutters. The machine's control system optimizes tool paths to minimize cycle time while maintaining surface finish requirements. Each tool change takes just 8 seconds, faster than most operators could manually change a single tool. The integrated measuring system continuously monitors dimensional accuracy throughout the machining process. If the system detects tool wear or dimensional drift, it automatically adjusts cutting parameters or initiates tool changes. This closed-loop control maintains tolerances of plus or minus 0.005 millimeters across features that span the entire component. The final operations create complex internal geometries that would be impossible with conventional machining. The machine's simultaneous 5-axis capability allows cutting tools to reach areas that would require special fixtures or multiple setups on traditional equipment. This represents the future of precision manufacturing, complete components with complex geometries produced in single setups with unprecedented accuracy and efficiency. Our final stop takes us to RoK Technic's comprehensive LPG cylinder production line, a fascinating glimpse into how those familiar propane tanks are manufactured to withstand extreme pressures while maintaining perfect safety standards. The journey begins with high-strength steel sheets, typically grade P460 or similar pressure vessel steels. The plasma cutting system you're watching creates perfectly circular blanks for the cylinder heads and precisely sized rectangles for the cylinder bodies. Each cut is programmed to account for the slight material distortion that occurs during subsequent forming operations. The deep drawing operation transforms flat steel circles into the characteristic domed ends of LPG cylinders. This massive hydraulic press applies over 800 tons of force while carefully controlling the material flow to prevent tearing or wrinkles. The drawing process work hardens the steel, actually increasing its strength by about 15%. Watch as the body-forming machine rolls flat steel into perfect cylinders. The seam welding operation you're seeing is critical. This longitudinal weld will be subjected to internal pressures up to 30 bars. The automatic welding system uses a combination of submerged arc welding for speed and TIG welding for the critical root pass, ensuring complete penetration and porosity-free welds. The circular seam welding operation that attaches the domed ends requires extraordinary precision. The welding head rotates around the cylinder while maintaining perfect arc length and travel speed. Any deviation would create weak points that could fail under pressure. The automated system maintains welding parameters within 2% tolerance throughout the entire 360-degree weld. This is the stress relief heat treatment furnace, where cylinders are heated to 580 degrees Celsius and then slowly cooled over 6 hours. This process eliminates residual stresses from welding and forming operations that could lead to premature failure. The temperature is controlled within plus or minus 10 degrees throughout the cylinder volume. Every single cylinder undergoes hydrostatic pressure testing at 1.5 times its working pressure. That's 45 bars of water pressure. The cylinder must hold this pressure for 30 seconds without any measurable expansion or leakage. Automated test equipment measures volumetric expansion to ensure the cylinder returns to its original dimensions after pressure release. The final operations include valve seat machining, surface coating, and final inspection. The valve seat must be perfectly flat and concentric to ensure proper valve sealing. Each cylinder receives a protective coating system designed to withstand 10 years of outdoor exposure while maintaining structural integrity. Before leaving the factory, each cylinder receives permanent markings, including manufacturing date, test pressure, and certification numbers. This traceability ensures that every cylinder can be tracked throughout its service life, which for LPG cylinders is typically 15 years with periodic recertification. The entire production line can produce up to 2,000 cylinders per day, each one meeting or exceeding international safety standards. What you've witnessed represents the culmination of decades of pressure vessel technology development.